In section 2.5, we're going to be starting to take a look at absolute value functions and their graphs. An absolute value function, as we have here in this top equation, is formed by f of x is equal to the absolute value of mx plus b, which as you would know would be a line, plus a value of c. And so this absolute value function is, we're going to, over the next number of days, be looking at how it's stretched, shrunk, vertically shifted, horizontally shifted, and flipped. But the first thing and the most important part of an absolute value function is very merely to find the vertex. And the way we find the vertex is we set that inside of the absolute value equal to 0. So this inside is that mx plus b. And then we solve that for x. And so that's going to be your x value. And then the y value is what's added or subtracted outside. So this y value, this plus c or this minus c, has to do with shifting things. And then once we've found that vertex, we're going to plot a point to the left and plot a point to the right side of the vertex, and then also plot their mirror points. So let me show you what this is going to look like with a very simple starting off point of y equals the absolute value of 2x. So our first step in this process is going to be very simply take that value of 2x, set it equal to 0. Obviously we divide both sides by 2, so we get x equals 0. Now, knowing that x equals 0, we have a vertex of 0 comma blank. Now we take that value of 0 comma blank and we plug it in, y equals 2 comma 0, and that equals 0. So my second value leads to a final vertex point of 0 comma 0. So I'm going to plot that in red over here on the graph. So this is the vertex. Now, absolute value is always in the shape of a v. So anytime you see a function that has the absolute value of something, it's going to be in the shape of a v. So it's shaped like a v. And we're going to learn how that works. Now, let's plot some points. We have our function, the absolute value of 2x. So if x equals 0, we've always shown that 2 times 0, absolute value, is 0. Let's plot the value 1. 2 times 1, absolute value is 2. And plot the value positive 2. So 2 times 2, absolute value of 4 is 4. So I'm going to plot these points 1 comma 2, 2 comma 4. Now an absolute value function takes everything that's outputs a positive out of it. So let's plug in the value negative 1. So 2 times negative 1 is negative 2, and the absolute value of negative 2 is 2. So I'm going to put this in green. So that's the point negative 1, 2. Now, do you notice that the first blue dot and the green dot are reflexive on the y-axis? Well, let's look at the next value at negative 2. 2 times negative 2 is negative 4. Absolute value negative 4 is 4. And so now you see the second green dot is also reflexive on this, which gives us a final function that's going to look just like this, where the blue line is reflected over the y-axis to the green line. And that function really gives us this value, this absolute value function, and what it looks like. Now, it's not a perfect 45-degree V because of that number 2. But what hopefully you are seeing here is this is reflected on the y-axis of the values that are green and the values that are blue, because we have taken an absolute value function and taken everything that was negative and made it all positive. Let's take a look at the next page and see how this is going to be a difference when we have a 2x minus 6 on the inside. Well, once again, we're going to take that 2x minus 6 and we're going to set it equal to 0, getting 2x equals 6, divide by 2 and get x equals 3. This gives us a vertex of 3 comma blank. So the question is, what is that value at x equals 3? So let's plug that in. 2 times 3 minus 6, that's 6 minus 6, and that's what equals our y value. So the absolute value of that is the absolute value of 0, which is 0. So we have the point 3 comma 0, because it's the function, the absolute value of 2x minus 6. So 2 times 3 minus 6, which is 0. So I'm going to put a large red dot once again on there. And now I'm going to shift to blue. And I'm going to take values to the right of that, the points 4 and 5. So 2 times 4 minus 6, that's 8 minus 6, which is 2, and the absolute value is 2. 4 comma 2. And then lastly, I'm going to take the value 5. So that gives me 10 minus 6, which is 4, 5 comma 4. Now this is going to have the same characteristics as the last problem, but just to show you how it works, we're going to plug in a value left of that red dot, left of that vertex, plug in the value 2. 2 times 2 minus 6 is 4 minus 6, which is negative 2, and the absolute value negative 2 is 2. And right away you see that these 2 points, the green dot and the first blue dot, are reflexive. If we plug in the value 1, I think you can also predict at this point 2 minus 6 is negative 4, absolute value negative 4 is positive 4, and so there you see that reflexive nature reflecting over the value where y and x form the vertex point. So I'm just going to draw our absolute value equation here. You see how it is symmetrical. We need to make sure we put arrows on each end because there's more off the graph, as we've said on many occasions, than on the graph. So that's just the basics on how we're going to look at the absolute value if we first find the function by finding the vertex first. So hopefully that's been pretty clear. What I'd like you to do now is I'd like to go to our next page and really take it some summary ideas and just talk about what an absolute value function does. Very simply, it takes our absolute value and it takes our output and it makes all of our outputs positive. So our outputs become positive when they come out of that absolute value function. So remember, an absolute value is in the shape of a V. So this is a second way to approach looking at the problem. I'm going to graph y equals x minus 3. So I start at negative 3 and I put a dot, and then my slope is 1, and I'm just going to go up as a slope of 1 all the way on my graph here. Now, knowing that's a slope of 1, I say, where are my y values positive? Well, my y values are positive beginning at 3 and going up to the right. And so because they're positive beginning at 3 going up to the right, those are functions I'm going to consider. However, I'm going to draw in green these functions down here that are not positive as outputs. So I'd like you to think of all of those green values becoming positive. What do I mean by that? Very simply, this value at 2 is going to flip up over the y-axis, over the x-axis to positive 1. All right? This value in magenta down here at negative 2, 1, negative 2 is going to flip up to positive 2. This value down here at 0, negative 3 is going to become positive 3. This value down here at negative 4 is going to become positive 4, because all of those values are flipped over and then they're going to become positive, which is going to give us a line moving up here to the right for our final answer. So the green is not our final answer, but instead the red plus the blue become our absolute value graph. Now, something I want you to notice, that this graph is very similar to our original parent graph of an absolute value function. In the parent graph of the absolute value function, notice there is a shift between this purple dotted graph and the red-blue graph, and it shifted 3 units to the right. So I'm just going to write a little note there, shifted 3 right. Okay? Let's take a look at this second one to the right, 2x plus 1. So I'm going to graph 2x plus 1, so there's the 1. Here's my slope of 2, and I'm going to put all my points here, and then I'm going to draw my line. Now I'm going to stop my line at the x-axis, and I'm going to start it up again going down. So all of these second points on the bottom half, everything that is below the y-axis is going to be reflected on that x-axis and flip up. So negative 1 becomes positive 1. Negative 3 becomes positive 3. Negative 5 becomes positive 5. And very quickly, once again, you see your value as your green line comes down and touches the x-axis of our graph. Now, where does it touch? Specifically, it's going to touch where 2x plus 1 equals 0. So 2x equals negative 1, so x equals negative 1/2. So that point right there, where we zoom in, that point is at negative 1/2, 0. That's the vertex. Negative 1/2, comma, 0. So just as we're kind of summarizing that, there's a lot of different ways to do this with a table of values or with flipping them up over the x-axis. Let's look down here at these bottom two. 3x minus 4. I'm going to take that 3x minus 4. I'm going to set it equal to 0. That means 3x equals 4 and x equals 4/3. So as we work through this, the value 4/3 right here, give or take, is going to be our vertex point. Let's see how this pans out. Let's take 3x minus 4 and we're going to graph that point. So 3x minus 4, start down there at negative 4, go up 3/1, up 3/1, up 3/1, etc. And I'm going to graph my line just like so. Now this value of 3x minus 4, it's going to be crucial to understand once again that the values that are below the x-axis, the values that are down here, are all going to flip over the x-axis up to positive. So this negative 1 becomes positive 1, this negative 4 becomes positive 4, and so on and so forth. And so that's going to give us a green line that's flipped right there. Now, where are those 2 points meeting? As we talked about before, that vertex is the point 4/3, comma, 0. So, on page 1, we talked about how do we use a table of values to graph, and we saw how it flipped there reflexive over the y-axis and then shifted on example 2. In this example 3, we're talking about how we do a visual flip over the x-axis, but in all cases, our absolute values will be in the shape of a V. Now, let's look at our last one, x plus 2. Well, x plus 2 equals 0. That means x equals negative 2. So there's going to be our vertex. Let's graph x plus 2. Well, the first y-intercept is there and has a slope of 1. So it looks like our slope of 1 is going to be very consistent. I'm going to have my 2 lines there, 2 segments. I apologize. I'm going to highlight the values below the x-axis, and then I'm going to flip all those values, positive 1, positive 2, positive 3, positive 4, and positive 5, giving me my absolute value function, which is a V, flipped over the x-axis, where the negative red line flips up above because the absolute value takes an output and makes it positive. All right, now we can use our calculators to do a lot of this. So what I would like to do is walk you through how we would use our calculator to think through this material and use our calculator possibly even to check our answers. So here's what we're going to do. We're going to go to our calculator and we're going to plug in the value and we're going to press y equals. So as I hit my screen, my buttons are going to turn red. So there you see the y equals turns red. Now, if for some reason you have one of these plot 1, plot 2, or plot 3 functions that are blackened, then you need to hit enter to make them look white like mine are with the background. So first, we're going to press the math button, which is underneath the green alpha button. And then we're going to arrow over to number. And we're going to hit enter or the value 1 for the absolute value. So now you have absolute value symbols. Now we're going to enter our equation, which is going to be x minus 1 in the absolute value minus 1. So we hit x minus 1. Now I hit the arrow, and we're going to also say minus 1 more. Now we need to give a window for our format, and so our window, we're going to have a standard window, which is Z6, the Z standard. So I hit the number 6. And now it's going to graph our absolute value function for us. And here you see. Now that doesn't really look like a perfect 45-degree V. And the reason is because the graph has been stretched horizontally. So we reformat it by hitting zoom again. And now we hit the number 5 for Z square. And now as you look at our graph, our dots horizontally are proportionately the same as our dots vertically. and you see our graph has been shifted to the right one and down one. So that being said, let's go back to y equals, and now let's instead graph our 2x minus 6 absolute value. Do you remember how to do this? Well, we hit math, we go over to number, we hit enter, we're going to plug in 2x minus 6. And this should look just like our other problem before. So we're going to hit graph this time because our zoom is already set. And there we show our proportions are correct. It's going to come down at 3 and go back up at positive 3. But it's a little bit narrower, and that narrow function is because of our 2 in front of the x. Now, one unique thing I'm going to show you, if you hit second table, now it's going to make up a table for you and give all the values. And so I'm going to arrow down here to where I get to the vertex. And I'm going to try to get that value of 3 so it's centered kind of in our problem. So here you see our value of 3. And now as we look symmetrically over at the y values, you see if you go up or down 1, you get to 2, up or down next step to 4, and then to 6, and then to 8, and then to 10, and you begin to see that symmetry of our problem. So, very simply, then we can go back to our real problem. And we can graph this with those values. So, 3, 0, over 1 up 2, over 1 up 2, over 1 up 2, and then the reflected points, back 1 up 2, back 1 up 2, back 1 up 2. And there is the graph of our absolute value function of 2x minus 6. All right, so that's just a brief introduction as to how to use our calculators to do this. What now we're going to do is continue to practice that, and we're going to look at the next page where we're asked to graph x minus 4 on a calculator, and then we're going to practice doing these other ones and predict how the shifts happen. So let's continue to practice together. Here we go. We're going to go back to y equals. We're going to clear this out. Do you remember how to get absolute value? Hopefully by now you do. Math, over to number, enter, and we're going to plug in a 2, so I got to hit second insert, a 2, and then on the inside of my absolute value I'm going to put x minus 4. Alright, little predictions what this is going to be. I hope maybe you can think about it. The x minus 4 is going to cause it to shift, and the 2 is going to cause it to be skinnier. So here we are looking at our problem. 2x minus 4 with the x minus 4 in parentheses. Do you see how it comes down and it has shifted 4 units to the right? Well, let's make a note of that, and let's start to see some predictions. So what we have here, it is the shape of a V. Second, it is narrow. And third, it has a right shift of 4 units. Now, why is it narrow? It's the shape of a V because it is a positive. It's narrow because the number in front of the absolute value is greater than 1. And it's shifted to the right 4 because if x minus 4 were set equal to 0, then x is equal to 4. All right, now let's look at our next one. Negative 2 times the absolute value of x minus 4. So I'm going to change this just slightly by hitting in second insert, and I'm going to stick in an opposite sign. Nothing else has changed, so now I'm going to hit the graph and I'm going to see what a minus sign in front causes it to do. Can you guess? Well, there you see. It takes what used to be a valley and it turns it into a mountain, as I would call it. So this minus sign in front, this minus sign causes it to be a mountain shape. The 2 here in red causes it to be narrow with a slope of 2. And finally, the x minus 4 causes it to shift right 4. All right, let's add a little bit more. Now let's make a prediction. We have a 2 in front, x minus 4 in the middle, and a plus 2 at the end. Let's place that in to our graph. So we're going to get rid of that negative sign. So I'm going to hit delete. We still have an x minus 4, but now at the end, we're being asked to insert a plus 2. Let's see what that happens as we put that on our graph. Maybe you can predict if it's a positive, it might be a V again. Will it still be shifted over 4? It is, but look, it moved up 2 as a result. And that up 2 is a very unique situation. So let's kind of do some labeling here. Once again, because this is positive, it's a V. Because of this is a 2, it's narrow with a slope of 2. Because we have x minus 4, it shifts to the right 4. And then at the end, because we have a plus 2, it shifts up 2. So we're starting to build and see some patterns on our problems. Let's make a prediction on our last one. Our last one, y equals 2, absolute value x minus 4 minus 2. So we go back to our y equals 2, x minus 4, and instead of a plus 2 at the end, it's a minus 2. So I'm going to put a minus in here, not an opposite side, but a minus. Let's take a look at the graph. Hopefully by now you can make some predictions that that minus 2 is going to have some implications. And what do you know? Instead of pushing it up 2 units, it pushed it down 2 units. So let's just do that summary here as we're summarizing this. Because it's a plus, it is a V shape. Because it is a 2, okay, it's going to be narrow with a slope of 2. Because it's x minus 4, once again it's right 4, but now because it's a minus 2, it is down 2. And in comparison, that minus 2 versus the plus 2, one pushed it up, one pushed it down. So this is just a quick summary using our graphing calculator to experiment and see how things are going to pan out. So as we summarize, we talked about learning how to use our graphing calculator in this second part. In the part 2, we talked about how an absolute value flips things that are outputs that are negative and makes them positive. And then in part 1, we talked about how to use a table and do that. Now, I need to remind you that your calculator will make a table for you. For example, on this very last problem, if we go back to our calculator and we were to hit second table, it's going to show us a table that exactly gives us all the values of this, and we see our low point is right here at -2. I hope this has been helpful in helping you understand more about absolute values as we initially do this. We have a short homework problem tonight. It's just numbers 33 through 38 down here, and all I would like you to do is just graph it using one of these 3 methods, flipping, values, shifting, finding the vertex, making a table of values, and then hopefully you're starting to see these ideas, and then check each one of these on your calculator.